Hi all, welcome to Chemakhilam Feed the Chemistry. Today we can discuss how to find out structure of a compound using NMR values. If you did not watch videos related to spectroscopy, please watch all those things. Then only you will be able to solve the questions. I will give the link in the description box. Also, you can check the playlist. Our first question is, compound displays the following spectral data, the correct structure of the compound. NMR 2.5 singlet 3 hydrogen, 3.8 singlet 3 hydrogen, 6.9 doublet, J equal to 8 heads 2 hydrogen, 7.8 doublet, J equal to 8 heads 2 hydrogen. So C13 NMR given, C13 NMR values 197, 165, 130, 129, 114, 56, 126 ppm, and this question asked in NET June 2016. And these are the options. How we can solve this question? First, we can take this value 3.8 singlet 3 hydrogen. This value mean by presence of OCH3, and always remember this value, or note down this value 3.8 singlet 3 hydrogen. It indicates the presence of OCH3 group, and this value will help you to find out the structure. If you are working on this structural elucidation questions, you can see that almost every questions are from like this. One ketone will be there, one alkoxy group will be there. So in that case, you will be able to solve the question with this value. If there is a peak correspond to 3.8 and it's a singlet with 3 hydrogen, the group will be OCH3. And here you can see the range. If OCH3 is present, then there will be a peak at 3.45 to 4. If there is a OCH2 group, then the value will be 4 to 4.5 ppm. If there is a OCH group, the value will be 4.5 to 5. The value is, you can remember these values very easily. OCH3 means 3.5 to 4, 4 to 4.5 means OCH2, and 4.5 to 5 means it is OCH, and 3.8 singlet 3 hydrogen means the presence of OCH3. And while using this value, we can see in A OCH3 is present, in B also OCH3 is present, in C also OCH3 is present, but in D the group OCH3 is not there. The alkoxy, the methoxy group is not there. So we can delete this option. Always solve this kind of question by elimination method. Okay, OCH3 is absent in D, so we can eliminate that option. Rest ABC is there, then we can see the next value, that is 2.5 singlet 3 hydrogen, and this will indicate the presence of CH3 that is attached to a carbonyl group. That means here in A it is present, in C it is present. So we can cut the option B. Here no CH3 is available. This means OCH3. This we already counted here. After that, no CH3 is available in option B. Now A and C remaining. Among these, which one is our compound? Here you can see 6.9 doublet, J equal to 8 heads 2 hydrogen, 7.8 doublet to J equal to 8 heads 2 hydrogen. These values are correspond to aromatic proton, or the phenyl ring protons are these two. Now our option is A and C. Here you can see that 2 hydrogen 1 doublet and 2 hydrogen another doublet. That means 2 values are given. That means 2 kinds of hydrogens are present. And A and C we can check how it is there. In A, these 2 hydrogen will give 1 signal, and this 2 hydrogen will give 1 signal. And this hydrogen means it can split. The hydrogen present here can split this one in 2ni plus 1, that we already seen in previous videos. So this hydrogen will appear as a doublet. Also this hydrogen will appear as a doublet. So both this hydrogen and these hydrogens are same, this and these are same, so two signals are there and both are what? Doublet. Now coming to this C, this hydrogen, this is there is a hydrogen here and it cannot be coupled with any of the other hydrogen, so it will act as a singlet. Then coming to this one, it will be a doublet. Here a multiplet. How it become a multiplet? Here one hydrogen is there, here one hydrogen is there, so this can split this one and this also can split. Okay, generally multiplet means more than 2, we are considering as multiplet. This one act as a doublet. So in C, one singlet, two doublet and one multiplet, and almost 4 types of hydrogens are present. But in A, 2 types of hydrogens are present and both are what? Doublet. Now it's satisfying all the values, so we can cut the option C and the correct answer will be A. Like this, you have to answer all the questions. By elimination method only you can solve the question, otherwise you will get confused. Okay, I think it's clear to you. This value, always remember, OCH3 3.8 singlet 3 hydrogen, and near to 2.5 singlet 3 hydrogen means one CH3 group is attached to this carbonyl group. Oh, and this J equal to 8 heads means it's a para substitution. Here you can see in A it is a para compound. I think this question is clear to you. If you have any doubt, you can ask. Next question. A compound displays the following spectral data: the correct structure of the compound. Proton NMR 3.59 singlet 3 hydrogen, 3.32 triplet 2 hydrogen, 2.25 triplet 2 hydrogen, 1.85 multiplet 2 hydrogen, 1.73 multiplet 2 hydrogen, and C13 NMR 174, 51, 32.9, 32.8, 31, 23 ppm. And this question asked in June 2017. How we can solve this question? Like previous thing, we have an option of first we have to check whether there is a OCH3 group, and the range will be 3.5 to 4, that is singlet 3 hydrogen, and the first option is 3.59 singlet 3 hydrogen, that indicate the presence of OCH3 group, right? So in option A, there is no OCH3, this is OCH2CH3. And in option B also there is no OCH3, so we can cut option A and B. And coming to option C, there is an OCH3 group, and in D also there is an OCH3 group. Now coming to next option, that is there is 4 types of hydrogens are present. Now here 3.32, 2.25, 1.85 and 1.73, like that 4 types of hydrogen, different types of hydrogens are present other than this OCH3, and these 2 are triplet and 2 are multiplet. So we have to check in C and D which option is correct. First we have to find out C, other than OCH3, what will be the multiplicity of other hydrogen, that we have to check. For this, this mean it's attached to CH2, so this hydrogen will split into a triplet. This one will split into multiplet, and coming to this one, it also will be a multiplet. This one will be a triplet. So OCH3 we no need to consider. We already found or we understood that there is a OCH3 group. So eliminating this part, other we have to find, and this become triplet, and this how it become multiplet. Here 2 hydrogens are there, here 2 hydrogens are, overall 4 hydrogens. So there is splitting like 2Na plus 1 into 2Na plus 1. Okay, that we already discussed in previous classes. So this will be multiplet, and this will be multiplet, and this will be a triplet. Coming to D, this CH3 group will split into a triplet, and then this one multiplet, this one hydrogen also a multiplet, and this one will be a doublet. So here in C, 2 triplet and 2 multiplet. In D, 1 triplet, 2 multiplet and 1 doublet. Now we can check these options. There is 2 triplet and 2 multiplet. There is no doublet in this option. So we can tell that option D is wrong and option C is the correct answer. Okay, first we checked any OCH3 group is there. Then there is a peak. There is a peak 3 at 3.59, and it corresponds to OCH3. Like that, we eliminated A and B. And in C and D, the presence of OCH3 is there. So we consider other peaks, and for, we have to check the splitting pattern. And in C, there is 2 triplet and 2 multiplet, which is given in the question. And in here, no need to consider the C13 NMR. And here 1, 2, 3, 4, 5, 6 type of carbons are there. You can check 1, 2, 3, 4, 5, 6 type of carbons are there. That is what this C13 meant. For confirmation, if you know the values or if you are comfortable with the C13 values, you can apply that one, but always try with the proton number. That will be more accurate. Okay, here option C is the correct answer. Next, question number 3. Partial spectroscopic data is given below for an organic compound, and first is 4 signal between tau value 120 to 150 ppm in C13 spectrum, and 2 doublet between tau value 6.8 to 8.5 ppm in H1 NMR spectrum, and absorption band at 1724 cm inverse in IR spectrum. We have this option A, B, C, D. 4 options are there, and it's given that 4 signal in C13 NMR. And the value is 120 to 150, and in proton NMR there is 2 doublet in this range 6.8 to 8.5 ppm, and also one IR spectrum IR value also given. You can any of the value you can choose, or how to approach this question, that is up to you, but here we can try with the first option. That is C13 NMR. There is a value. There is between values between 120 to 150, and this range means it is ring phenyl ring carbons. That is aromatic, or this ring carbons are lies in 120 to 150 ppm. Chemical shift value in C13 we already discussed, that you can watch. So 4 signal will be there. That means 4 types of carbon should be there in C13 NMR. That is this peak. This don't consider all the molecule, only this aromatic part or the phenyl ring part only consider. There you can find 4 carbons. Consider A, compound A. Here 1, 2, 3, 4, 5, 6 type of carbons are there. So we can eliminate this option. Consider B. Here 1, 2, 3, 4 types of carbons. So here 4 signal means 4 type of carbon is there. So we can take this option B. Consider option C. Here also overall 6 type of carbons are there. I mean this phenyl ring carbon only considering. Okay, 6 type of carbons are there, so this option also we can eliminate. Coming to option D, here also you can see 1, 2, 3, 4 types of carbons are there. So from option 1 or the data 1, we can eliminate 2 structures. Now B and D are remaining. Coming to next point, 2 doublet between 6.8 to 8.5. That also mean that this value also correspond to the aromatic hydrogens. And in option B, this where we place this 2, that will give one type of hydrogen, and this carbon, this C3 carbon containing hydrogen, that will be signal 2. So there is 2 signal from option B, and from option D also you can see 2 signals. Okay, 2 hydrogen signals are there, and both are doublet. Option B and D, this satisfying this condition. So from this second option, we are not able to differentiate B and D. Okay, in both 2 types of hydrogens are there, and both are doublet. So there is no use with this one. If you are taking first this option, if you are taking, then also you can eliminate what A and C, because this doublet in this range means it's a para compound. So option A is not a para compound, option C is also not a para compound. So like that also you can eliminate A and C. Okay. Now coming to next option, that is IR spectrum 1724. That means it's an alpha beta unsaturated ketone. 1724 means it's an alpha beta unsaturated compound. So in option B you can see this is carbonyl group, and this one, this carbon 1 is alpha carbon, and carbon 2 is the beta carbon. So this is an alpha beta unsaturated ketone. So the IR value correspond to 1724 is this alpha beta unsaturated ketone. Coming to option D, it is not an alpha beta unsaturated ketone, it's an ester. Okay, this also an ester, but you consider this part only. It's an alpha beta unsaturated compound, but here that is not there. So we can eliminate option D, and the correct answer is option B. And this carbonyl will have an absorption in the range of 1730 to 1750. Clear? First we eliminated 2 options by using either any of this option. We can eliminate A and C, and then rest is B and D, that we isolated with this IR spectrum 1724, that corresponding to alpha beta unsaturated ketone, and that is option B. And this is ester part, and this ester carbon will absorb at 1730 to 1750 centimeter inverse. Next question. A compound displays the following spectral data, the correct structure of the compound. This is a question from NET December 2018. IR peak is 1720 centimeter inverse, and this HNMR is 6.2 BR. BR means broad singlet 1 hydrogen, 5.5 broad singlet 1 hydrogen, and 4.2 quintet 2 hydrogen, and 2 singlet 3 hydrogen, 1.1 triplet 3 hydrogen. And these are our options. And 1720 means there is a carbonyl group. Okay. And there is an alpha beta unsaturation also there, but we can start with this proton NMR, and finally if there is 2 structures, we can eliminate those with the IR value. Okay, now consider these values. OCH3, any OCH3 is present? 3.5 to 4, any values are there? No, so there is no OCH3. And next is OCH2. OCH2 4 to 4.5. 4.5 OCH2 group is there, right? Here also OCH2 is there, here also OCH2 is there. Is there any value in between 4 and 4.5? Yes, there is a value 4.2 quintet 2 hydrogen. Such a value is there. That means the presence of OCH2 group. And OCH2 group means here OCH2 CH3, OCH2 CH3, and that CH3 is what? This 1.1 triplet 3 hydrogen. So we can eliminate option A, there is no OCH2 group. Also we can eliminate option C, there is no OCH2 group. Here this OCH2 group correspond to 4.2, and it is attached to a CH3 group, that is what? 1.1 triplet 3 hydrogen. Next, these 2 values 6.2 broad and 5.5 broad, that indicate a double bond. that indicate a double bond. So here also one double bond is there, here also one double bond is there, this is cis. The structure will be D, but next how we can differentiate, that also we can check. Now you can see IR value, it is an alpha beta unsaturated ketone, and consider B, whether it is an alpha beta unsaturated ketone. Yes, it is an alpha beta unsaturated ketone. Here this is alpha carbon, this is beta carbon, so this is alpha beta unsaturated ketone. Coming to option D, this also an alpha beta unsaturated ketone. But what is the difference between B and D? Here you can see this double bond is left side, and this lone pair, the oxygen with the lone pair is its right side. But coming to option D, it is like double bond O, double bond C, double bond C, then O. If you watch this IR related videos, you can see that the value from 1700 it is decreases to 1680 centimeter inverse in these kind of compounds, and this value is more in these kind of compounds. So for option D, the value will be 1680 centimeter inverse. So we can cut option D, and the correct answer will be option B. Why such a difference, or what the difference between these two? You can watch IR videos. Two videos are there related to IR. You can watch that thing, so it will be very clear to you. Now we can only solve this question. I don't want to go in detail because there I did a detailed video. Okay, now our problem solved. Our option is the correct answer is option B. First we checked with OCH2, later with this compounds, this alkene peaks. Then using IR values, we eliminated the incorrect options and selected this correct answer. Now last question, the compound with the molecular formula C10H12O2 showed a strong IR band at 1720 centimeter inverse, a peak at M by Z 122 in the mass spectrum, and the following NMR signals: 8.1 to 8, 2 hydrogen multiplied, 7.6 to 7.5, 1 hydrogen multiplied, 7.5 to 7.3, 2 hydrogen multiplied, and 4.3 2 hydrogen triplet, 1.8 2 hydrogen sextet, and 1 3 hydrogen triplet. Find the structure of the compound, and this question asked in GATE 2020, and these are the options. First we have to check about whether there is an OCH3 group is there, OCH2 group is there, like that. Okay, before that there is a hint, or we can eliminate two options very easily. First we can try that is mean by or this compound A is an ester. Option C is also an ester. Option B is a ketone. Option D is an acid. For acid group, this delta value should be above 10 or 10 to 12 ppm. Normally we are considering for COOH hydrogens, or this carboxylic acid hydrogen, the delta value will lies in 10 to 12 ppm. There is no value above 10, so we can eliminate what? Option D. Now here presence of OH. This presence of OH we can identify with 4.31 proton. Here also 4.31 peak is there, but it is 2 hydrogen triplet. Okay, this OH means it will write as 4.31 hydrogen singlet exchangeable, like that it will write. So there is no such a peak in this given data, so we can eliminate what? Option B. So very easily we eliminated two option B and option D. Now we can consider the mass data. We did not do any video based on mass data, but still you can do this problem. That molecular mass of A and C is 164.08, and given that peak at M by Z equal to 122. What the difference? Difference between these two is nearly 42 or 43. Okay, around 42 there is a difference. That means a part or a group that is eliminating from this compound to give m by z equal to 122, and the eliminating part have a value of or the mass of 42. That is what it is meant by. So here you can see that this O and this carbon, this bond is very weak, so we can cut, or this bond we can break. After breaking, we are getting CH2 CH3, and which have a mass of 29. Okay, next coming to this compound, here also this O and this carbon, oxygen and carbon bond is very weak. We can break this bond, and after breaking you will get a fraction CH3 CH2 CH2, and that have a value of nearly 43. So from this you will able to understand that which is the compound. Now we can check the or confirm with the other values. Okay, here this hydrogen means it's a singlet, and this is a quintet, this is a triplet, right? Here there is no coupling, so it will act as a singlet, and here it is splitted by this 3 hydrogen to form 4, that is quartet, sorry, not quintet, quartet, and here 2 hydrogens are there in neighbor, so it will split into triplet. Coming to this compound, this will be a triplet, and this will be a sextet, this will be a triplet. Here you can see this is CH3, 3 hydrogens from here, and this is 2 hydrogens, overall 5 hydrogens are there. So in option you can see that there is a triplet, there is a sextet, and there is a triplet. So in option A it is a singlet, there is no option like or there is no peak like a singlet, and these first 2 peaks correspond to this phenyl ring. Okay, it's common in both, so we have to consider only this part. No need to waste your time on these things. Here 1 singlet, 1 quartet, and 1 triplet. Here 2 triplet and 1 sextet. That is what here mentioned. So the structure is option C. I think it is clear to you. If you have any doubt on these questions, you can ask. If you like this video, like, share and subscribe. Chemakhilam. You can follow me on Instagram, Facebook. Also, you can direct mail me. And don't forget to press the bell button, then only you will get notification when I am uploading videos. Thank you for watching.